Today we're going to be tackling a two-sample t-test, and this one's going to have to do with not proportions. This is going to have to do with means. So it's just going to be a little bit different, but the good news is we're not going to be changing up that much. All right, so let's take a look at what we're presented here. A random sample of 40 high school seniors from Massachusetts had an average SAT score of 1080. A random sample of 40 high school seniors from California had an average SAT score of 1120. Is there evidence that California seniors had higher average SAT scores than Massachusetts seniors? All right, we're going to be testing this out today. We're going to be running a hypothesis test. All right, so first things first, we need a null and we need an alternate hypothesis. Good news is, not much has really changed here. It's still going to be kind of the same rules. The only difference is instead of using P, we're going to be using means. So what am I trying to prove here? I'm trying to prove that, well, let's see, I'm going to start out with the mean of California students is equal to the mean of Massachusetts students. Because our null hypothesis is always going to be an equal statement. And you notice how I'm not really throwing any values in here. The other value I could throw in here if I wanted to, I could do the mu of California minus mu of Massachusetts equals 0. Notice how I'm not throwing in any SAT scores in here, though. That's important. You're not throwing any values in here except for that 0. You're just trying to establish that your null is that they're the same. You're assuming they're the same here. And notice how I used mu. This represents the mean of a parameter. This is a parameter. This is the mean of an entire population. That's what we use when we're trying to establish the mean of a population. Now, what am I trying to prove? It says, is there evidence that California students had a higher average? If that's the case, it's going to be greater. So I'm going to do mu of California is greater than mu of Massachusetts. I'll change this to an uppercase A to keep it consistent. But again, it's an inequality statement, just like we did before. Now, since we're trying to prove that California is higher, it's going to be greater. If I were just trying to prove that they were different, it would be doesn't equal, like this. But I'm trying to prove that California is greater. Now, if I want to throw a value in here, you can do that. But this is what it would have to look like. You could do mu of California minus mu of Massachusetts. I'm going to keep 0 in here. Now, if California was greater than Massachusetts, when I subtracted these two values, I'd be getting something positive, so it would be greater than 0. So those are my options here. These are my options for my null and my alternate hypotheses. But notice I didn't throw any values in here. It's either going to be they equal each other, and one is greater than the other if I want to go this route. If I want to go this route, when I subtract them, I get 0. Or in this case, it's greater than 0. All right, so I got my null and my alternate established. Next, I want to check my conditions. All right, so your conditions, again, they don't really change from when we've done confidence intervals that have dealt with means before. The only difference now is you have to check for both. So first things first, random. Is this based on a random sample? Let's check it out. Both random samples. Yes, random sample, random sample. Notice I circled those. That's good. I'll put C above because I circled them. I established that I know that they're random. All right, now next one, 10% condition. I have to check this for both of them. All right, so I had 40. Let's see, is that less than or equal to 10% of California seniors who took the SAT? I think it's fair to say that 40 is less than 10%. I've got to do that for Massachusetts as well. It's 40 less than 10% of Massachusetts seniors who took that SAT. Certainly is, so I'm giving that a check mark. I've got two conditions out of the way. Your first instinct might be, hey, I just did large counts of proportions. I should do this for means. Doesn't work for this. The reason is, large counts are based on having successes and failures. We're looking at averages here. There's no real success and failure involved here. So here's how I would do it. Here's what this condition would be based on. We call this the large sample slash normal. Some people call it the central limit theorem. That's fine. Here's what we want to look at. We want to see if our sample size is greater than 30 or comes from normal population. How would I prove that? I would have to have some sort of histogram for each case, and then I would compare them. In this case, let's see, we had 40 for California. 40 is greater than 30, so I'm good. I don't have to draw a histogram or anything. I don't have to prove that. For Massachusetts, we had the same sample size in this case. We had 40 greater than 30. Absolutely, so I don't have to draw a histogram. Now remember, for your histogram, you can use different ranges and stuff. Some people use box plots. I don't necessarily advise using box plots because box plots don't necessarily clearly show spread. I usually recommend histograms or dot plots. But we've got all the tough stuff out of the way. We've got a null. We've got an alternate. We've got our conditions covered. Next, I'm going to be running a 2-sample t-test because it's based on means. Means are based on t-distributions, not normal distributions. All right, I'm not going to use norm CDF here. You don't use norm CDF because this isn't normal. So what I'm going to do instead is I'm going to pull up my calculator, and I'm going to make sure everything is clear. I'm going to go to stat. You're going to do the same thing. Go to tests. And if you go down here, we've got all sorts of options here. We've got z-test, t-test, 2-sample z-test. We want a 2-sample t-test, so I'm going to go to 4. All right, so instead, I'm going to go to stats. I'm missing something here, and I'm going to add this in right now. All right, so I'm going to just put this, let's see, I'm going to put this off to the side here. I'm going to close it. There we go. Come on. All right, I need a standard deviation. You typically need a standard deviation. One wasn't provided. So I'm going to provide a standard deviation. The standard deviation was, we'll say, 10 points. For Massachusetts. For California, we'll say the standard deviation was 12 points. Okay. Whoops, let me just fix some of that typing here. But you always need a standard deviation. That's pretty important. So typically that should be given. You might have to calculate it in some cases, but if that's the case, just use one variable stats in your calculator. But in this case, you'll notice it is given to you. So I just made it up. These statistics are made up, by the way. I'm not using anything pretty, I'm not using anything accurate here. I'm just making stuff up for the sake of doing a problem. So now we're going to go back to our calculator, and now we have a standard deviation. We can use it. All right, so the mean for my first sample, we'll go with, let's see, I'm going to go with California to enter first because that's the one we're going to be trying to prove is greater. So let's see, what do we have for our mean? 1120, okay. So let's go up here. 1120. We have standard deviation of 12 points. For Massachusetts, we had 1080. We have standard deviation of... I forgot to put my sample size here. This is why we do this, just to make sure that, we're on point here. So we enter in our mean, our standard deviation, and our sample size. We do the same thing down here, 1080. We go with our standard deviation here. We went with 10 points. Our sample size is 40 as well. All right. Now, what are we trying to prove? We're not trying to prove that they're necessarily equal, or not equal, excuse me. We're not trying to prove that California is less. We're trying to prove that California is more. So we're trying to prove that our first average is going to be greater than the second one. And then I would hit calculate. And you will notice I get all sorts of values here. I get a t statistic, which is my test statistic, and I also get my p-value. So I'm going to write that in down here. I'm going to write in that important stuff. So for my test statistic, T, I get a pretty high T statistic. 16.19-ish, we'll say, 196. Our p-value, we get something really low. 1.38 times 10 to the negative 26th. That is a very, very low p-value. And just like all hypothesis tests, we ain't really establishing the significance level at the beginning. If it's not established, always go with 0.05. So in this case, my p-value is less. Since my p-value is less than my significance level, I reject my null. I have enough evidence to prove California seniors had a higher SAT average than Massachusetts seniors. So just to recap, our null and our alternate hypotheses. Let's get rid of our calculator here. We're done with that. There we go. Our null, we established that our two averages were equal. Or we could do one average minus the other average equals 0. Those are your two choices. For our alternate, since this was one-sided, we were trying to prove one's greater than the other, I used an inequality here in both cases. Now, if I was just trying to prove that they're different, it would just be dozen equals. For my conditions, I established random. I established my 10% for both. And I established large sample / normal for both. In this case, it's n was greater than 30. I didn't have to use a histogram or a dot plot. In some cases, you might have to, or you might just have to refer to the fact that they tell you that it came from a normal sample or population. I then ran a 2-sample t-test on my calculator, in which I had to note my average, I had to notice my standard deviation, and I had to note my sample size. I took note of my test statistic and my p-value. And then, just like we've been doing, I used that p-value to establish a conclusion. In this case, since it was less than my significance level, I rejected my null hypothesis, and I was able to prove my alternate. So that's what we're going to be doing here with hypothesis tests that have to do with means when you're